Okay, so let's look at the next problem. So this problem asks for the intervals of increase and decrease, the local extreme values, and the concavity, and also we want to sketch the graph of the function. Let's look at the derivatives. The first derivative is 4x cubed minus 6x squared. So if we take into x squared parentheses 4x, no, let's take 2x squared parentheses, then this will be 2x minus 3, right? Okay. So the first derivative is 0 if x equals 0 and x equals 3 over 2. Let's take another derivative, second derivative. So the second derivative is 12x squared minus 12x. So this is 12x times x minus 1. So the second derivative is 0 if x equals 0 and x equals 1. Okay, so let's look at the signs of both f prime and f double prime. So what are the possible points? X equals 0, x equals 1, and x equals 3 over 2. So for the first derivative, when x is greater than 3 over 2, this is positive and this is positive, so the sign is positive here. And 3 over 2 is a single root, so the sign will change here. 1 is not a root of the first derivative, and this 0 is a double root, so this is also negative. For the second derivative, if x is greater than 1, this is positive, so these are positive, and at x equals 1 is a single root, we have a sign change, and here we have another sign change. Okay, so how can we draw the graph, and what are the inflection points and the local extreme values? So at x equals 0, this is an inflection point, and x equals 1 is another inflection point, and we have only so the function is decreasing here and then increasing here, which means that this is a minimum value, minimum point. Okay, so how do we sketch the graph? So this is, we will see later how to sketch graphs in more detail, but for now the function is decreasing until x equals 3 over 2, and it changes concavity, so the function is concave up, and then decreasing, so at x equals 0 this function is 1, and then it changes concavity, but it's still decreasing until x equals 1. At x equals 1 the function is 0. Let's look at these values first. F0 is 1, f1 is what? F1 is 0. What is f3 over 2? F3 over 2 is a negative value, and we can compute it to be minus 11 over 16. So at x equals 1 the function changes concavity again, so it makes a minimum value here, then increases, right? Something like this. So this is 3 over 2, and this value is negative 11 over 16. So the function has a minimum here, inflection point at these 2 points, and that's it.